But first, what is an electron? An electron is an extremely small negatively charged particle. These are orbiting around the nucleus of an atom or around a molecule near the speed of light. There's a ton of energy associated with these electrons. And redox chemistry specifically has to do with the concept of electron transfer. And what I mean by that is an electron is transferred from one atomic or molecular species to another. It isn't shared, it is transferred. And when we talk about the transfer of electrons, we mean in a very real way the transfer of energy. So if redox is the transfer of electrons, and electrons contain energy, then redox in a very real way is simply the transfer of energy. Now, many of you have probably seen this analogy because in Budapest we went over this. We all know intuitively that a ball perched on top of a hill, when I give it a nudge or push it, it rolls down the hill. We know this intuitively. We've seen it in our lives. Things roll downhill. What does the ball possess at the top of the hill that it no longer possesses at the bottom of the hill? And the answer is potential energy. The ball at the top of the hill has energy stored in the form of gravitational potential energy. But when given a push, the ball spontaneously releases its energy by rolling down the hill. This brings back the concept looking for a place to rest. There is a law in physics called entropy. And it's the concept that everything in this universe is looking for the lowest energy level, looking for a place to rest. And much like the ball rolling down the hill, electrons are very much the same. Electrons are looking for a place to rest. And this is what makes life possible. Everything on this planet is alive today because electrons have an ability to transfer while looking for a place to rest. And if we remember, the transfer of electrons is redox. So if you don't have the transfer of electrons or redox, you do not have life on this planet as we know it. Now we got back to this concept of redox as a contraction of two words, reduction and oxidation. Oxidation is lose, reduction is gain, oil rig. Now what that means is when an atom is oxidized or undergoes oxidation, it is losing an electron. When an atom is reduced, it is gaining an electron. So there's an electron transfer that happens. You see that on the image there. The question I'll often ask during this discussion is, why is the electron transferring? And then I will suggest that people go back to the ball rolling down the hill as an example. Why did the ball roll down the hill? The ball rolled down the hill to release its energy and find a resting state. Much like the ball, the electron transfers to find a resting state or a lower energy state. Now, in thermodynamics, we know that energy cannot be created or destroyed. And so if the electron possesses energy before it transfers, and then it transfers and no longer possesses that energy, what happens to that energy? If we cannot create or destroy energy, that means that energy must have been released or transferred to its surroundings. In the case of redox signaling molecules in the cell, if this molecule has been absorbed by the cell, that electron transfers, that energy is released and donated to the cell.